Jiva shopping over.
What shopping, sir?
New Year, no shopping.
No, sir.
No shopping.
Not today.
When?
Already over, sir.
Already over. Oh, super. Really? He's coming. He has to come to my ear. Actually, roads are very traffic. Yes, sir. We are living in heart of the city. The roads are somewhat good. You are coming from Ayer Bangla, na? Your father will go to income tax department and demand refund of income tax. Refund will double.
Of motion and friction. Yesterday we finished first law. So today, second law. It's a brief revision only. Understood? In detail, I will not go. You also not supposed to go. Okay? So already existed students. I don't need to tell about second law. What is second law? Newton first law. What did it describe? If a net external force is zero, how many states we have noticed? One is rest and other one is uniform motion in a straight line. That we discussed a lot in different cases. So second law is the reciprocal case. First law, Newton described if total external force is zero, what is the state of object? He narrated nicely. So reciprocal today. Reciprocal means here net external force is not equal to zero. What do you notice? One simple example. Usually board is nothing but ground only, na? Yes or no? Just imagine I placed one book on this ground. What will
Sir,
happen? Yeah,
sir, board is not clear, sir.
board is not clear. Huh?
Yes, sir, it's blurred. Now okay, sir.
Now okay, no?
Before it was blurred, sir. I think we can't receive.
Okay. No. Sir, I think might touched this. Okay. Any disturbance happen, please tell. Okay. Just imagine this is one book that has been placed on the ground. One guy pulling with some 10 Newton. This one person pulling with some 2 Newton. Let's say the mass of the book equal to how many kilogram? 1 kilogram. So what is the net force? Logically 10 minus 2.
Sir, it is blurred, I think.
Again blurred. Huh?
Yes, sir. If you are standing, it is focusing you, sir. The board is blurred.
Yes, sir.
The camera is maybe there's something on the camera.
When I'm going, I'm pushing the light towards
Maybe you know,
autofocus. No?
yes, sir.
Do you know any idea how to set it?
Sir, maybe video.
More settings. Huh?
Sir, that I know it, sir, yes.
Okay. Security settings. Huh?
Sir, not that. One more thing.
Yeah, again it went
Yeah,
zoom. Na? Okay, student, 1 minute.
So 1 second.
Yeah,
Now
auto-
sir, maybe due to focusing on it.
Then how to stop focus, autofocus? Srinidhi, once you go to board and go
Yes, sir.
near, walk here and there, just do some movement. Why it is happening like this?
Camera is focusing on things. Yes, sir, that camera is focusing. So maybe now.
Now you go and do the same thing, Srinidhi. Go and walk here and there.
Now I think it's happening.
Go. Now comfortable, na? Online back?
Yes, sir.
Okay. Okay, students. So
Next one. Sir, that. Yes, sir.
okay. So your net external force how much?
8.
What net external force is always? Big force minus
small force.
small force means 10 minus 2 is equal to how much? 8 Newton. And according to Newton's second law, so what I can write here? Net external force equal to how much? Mass into acceleration of that book. So tell me, yeah, what is acceleration of that book equal to? External force divided by mass. External force equal to how much? 8 divided by mass. Mass is how much? 1 kilogram. So that book is accelerating with what? 8 meter per second square. Understood? So here, this is called Newton's second law. I mean, the direction of the external force. In which direction that external force is acting, in that direction, acceleration will be there. Here the net external force is going right side, the book also accelerating in the right direction. The consequence of the second law is nothing but linear momentum. What is that? Every object has linear momentum. Or we can also call simply as a momentum. Momentum is nothing but when any bullet is in the state of rest or when it has any very small speed, you can catch it and you can play with it. But a bullet coming out of the gun, it is very terrific and dangerous. Why? Due to its large momentum. Momentum is a physical parameter which represents the danger or damage caused by the object. Are you understanding? Knife is there. When I throw you with a little velocity, you can catch. But a falling knife from the 20th story building, can you attempt to catch it? No, you can't. Yes, sir. Itla elandi jump chesi. Enga phone. Okay, so here I can write linear momentum equal to how much? Product of mass into velocity. Damage caused by object affecting how many factors? One is mass. This desk is there. I'm a light person. If I am sitting on the desk, nothing damage will happen. Correct? But if elephant is sitting, why? Damage is affected by the mass, first thing. Earlier I sat very slowly. Now from second floor I jumped. So I get damage. In fact, the desk also getting damage. Means damage is also affected by the speed of that object. That's what we join these two quantities which are affecting the momentum. So we have got linear momentum equal to how much? Mass into velocity. And in fact, it is also vector quantity, right? It depends on the direction of the velocity. For example, one bullet of mass m kilogram going in the right direction. So the direction of the momentum also going in the right direction. Understood? So I can also write according to Newton's second law. Force. Student, you have to be very, very careful. In our system, there is no rule that only single object should present. There is no protocol that only single force only should present. There is no such rule. That's what I have written. Net external force. Many objects may be present in one system. Multiple forces, multiple external forces also may present. So I can write vector sum of all external forces equal to how much here? Mass into acceleration of that object. So mass into what is acceleration of that object? Tell me. What is statement of the acceleration? Change in velocity of the object in a given time interval. Understood? So you can also write sum of all external forces equal to how much? M if you send inside that, what I can write? As the mass of the bullet is constant, I am treating M as a constant here. If you take rocket, can you keep mass as a constant? No. 99% of the body of the rocket containing fuel. If it is on earth, rocket means in the motion only we have to consider. Correct or not? When it started in motion, okay, the capsule will be emptied very, very quickly. The rocket containing not a single capsule, 3 capsule, 4 capsule also it will contain. As the tank is, that capsule is emptied, it will fall in the ocean. That's what rocket launching stations are constructed nearby the ocean only. Rocket is an example for what? Variable mass system. But we are not variable mass system. We are mass is constant. Na? That's what a mass I am sending inside the velocity. This is applicable for what system only? Only for which system? Constant mass system. It is not applicable for variable mass. So I can take mass of that object or bullet into V. So I can also write net external force equal to how much? Change in momentum by change in time taken. This is also another modified format of the linear momentum. Understood? The change in momentum is also called as impulse. What impulse? Linear impulse or just impulse? So here, impulse, you can define it as very large change in momentum. How can you define? Very large change in momentum in a very, very small time interval. So I can define change in momentum equal to how much here? External force and into change in time. Understood? This is the expression for what? Impulse. When we have to use this impulse, impulse is nothing but difference in momentum or change in momentum in very small time interval. You have to understand these terms qualitatively. Here, change in momentum means here this is very large change. What is this? Very large change. And but this is a very, very small interval. This expression, impulse expression, valid for only very little amount of time. Understood? Over a very little amount of time, this any force will become constant. So this expression is applicable for what? Only for constant force. Only for which force? Constant force. But there is no rule that always constant forces should act. It may be variable force also. In case of variable force, how can you calculate impulse? On either side, integration method you have to do. Understood? So I will write that point. If a force is variable, if F is variable, if F is what? Variable. So very small change in momentum, how much? F vector into dt. I want total change in momentum. What I have to do? Integrate on either side. What is the initial momentum? Let's say P1. What is the final momentum? P2. Initial time, let's say T1 seconds. Final time equal to how much? T2 seconds. What is integration of dp? P. Put the limits. So I mean P2 vector minus P1 vector equal to how much? Integration of force at any time t seconds into dt. This is the momentum, sorry, change in momentum or impulse when variable force acting. Star mark meaning you have to remember compulsory. When you remember such small things only, very great benefit you will get. Clear? While you are doing numericals only, very quickly, without wasting time, you can do. And one more thing, in your maths, in your mathematics, For example, y values I am taking on y-axis and x values I am taking on x-axis. What is this equation curve representing? Please respond. It is a parabolic equation only, na? You can write y square equal to how much? 4 into a into x. Yes or no? Sorry.
Yes, sir, correct only. Parabol.
4a x square or y is equal to
No, sir, y square equals to 4a. Correct only.
Sir,
y is equal to
x
4a.
square is equal to 4ay, sir.
Yes, yes.
Y square equals to 4.
X square is equal to 4ay.
No. X square equal to 4a. Why? Because it is bisecting. No?
Okay, yes, sir.
X square equal to.
Parabola on y-axis, sir.
Yes, correct only. It's a parabola. This bisecting y-axis. I remember y should not get power. That logic I know.
Sir, if it is y-axis, it is like that.
Yes. So what y can be written? X square by any 4 into a. Now I want to calculate area under the graph. Directly I cannot do. This is a ending point x na. For example, ending point, terminal point x. What is the y coordinate here? Tell me. Y is equal to how much?
X square by 4.
X square by 4a only, no? I want to calculate total area. You cannot do directly. So I will divide this into tiny rectangles. Say yes or no? Yes or no?
Yes, sir.
I will find area of the rectangle. Then I will add all area of rectangle. I mean, I will integrate all area of rectangle. I mean, integration method I am going to use. Let's say this rectangle at a distance x meter. Then what is its width? Del x or dx. That is of your choice. Let's say the length of this element how much? Y.
Sir, don't take it as x, sir, because you already have that x coordinate. So,
X is the final terminal point. I remembered. I will keep it in my mind. No problem. Understood? Now tell me what the area of the rectangle? dA is equal to how much?
dx into
Length into breadth only, na?
Yes, sir. Or dx.
I want total area under the graph. Such all rectangles I have to add. That addition is only called integration. Integrate on either side. What integration? 1 into dA? Area under the total curve is equal to how much? Integration of y value into dx. That's the concept you can also apply in the change in momentum also. If you plot the graph between force values I am taking on y-axis, position values I am taking on x-axis. For suppose if this is a force versus position graph, here also what I should take? I should take one small rectangle. Sorry, this is time now. Force versus time graph. This is a very small time t seconds. This is a what is the width of this element? dt. What is the length of this element? F. What is the area of this element? What is the area of this rectangular element? Rectangular element delta p equal to how much, student? F into dt. I want total momentum change. On either side, what I have to do? Integrate on either side. Means what I am trying to say, if any force versus time graph is given, the area under force versus time graph directly telling change in momentum or impulse. I'll write that point. Area under, this point is very important. Area under force versus time is telling what here? Impulse. This point is very important. Here, this is one wall strength. What is this? Rigid wall. One ball approaching towards wall with some velocity 10 meter per second. It is strike the wall and coming back with the same speed 10 meter per second. Time of contact between wall and ball is some 0.1 second. Let's say the mass of the ball equal to 1 kilogram. When ball is in contact with the wall, what will happen? Ball will be deformed like this, na? In the slow motion, if you have good visualization power ability, you can visualize like this. During the collision, ball is completely deformed like this, like oval shape. During that collision, ball will push the wall like this. For every action, there is an equal and opposite reaction. So ball, how it is pushing, with how much force it is pushing, wall also pushing with the same amount of force. Now my question, you people have to find the force on the wall or force on the ball. You just try. Take one pen and paper, everyone. Just try. Find the ball, how much force acting on the ball. Ball also will apply the same force. You just try and tell the answer, everyone. 0. Incorrect. Incorrect, man. Definitely some force is there, na Dharni? Dharni only, no? Means your logic FF cancels, so net force 0. Your logic that no. This force acting only on the ball. That force only acting on the wall. So you should not cancel. Only 0.1 second.
Sir,
Yeah.
1 Newton.
So Jiva replied 1 Newton. This is Jiva's answer.
Newton.
100 Newton. 100 Newton is Srinidhi answer.
And Jiva double E, sir. Why?
Srinidhi answer.
I don't know to read that.
That is Kannada.
I don't know Kannada. I
Okay.
want to read.
Srinidhi. This is Srinidhi. Srinidhi. This is Jiva. I will write. This is Jiva only, no?
Don't know, sir. I don't know to read.
Okay. So what is the total force acting on the ball? Respond. Change in momentum of the ball by change in time taken only, no? What does change in momentum mean? Final momentum means mv2 minus mv1 divided by total time taken. Say yes or no? What a mass?
Right, sir.
Wrong.
How, sir?
Correct? I am proving, na. I am doing, na. One only, yeah? I don't know. Dharani also supporting very strongly 1 Newton. Let me check it out. What is mass of the ball? 1. What is the final velocity of the ball?
10 meters.
Think and tell.
Minus 10 meter per second.
Very good. Minus 10. Minus 1 into what is the initial velocity of the ball? Plus 10. Correct?
Yes, sir.
What time taken? 0.1. To simplify how much?
-20.
-20 by
200
0.1. So minus 200 Newton. So
None of them is correct.
point goes to Quizmaster only. Okay. Understood. None of them is the correct answer. So one more. I'm very confident you will not do. Okay. Right? Shall I give?
Yes, sir.
Sir, it will be 200 Newton also, right, sir?
Minus means, Srinidhi, we are calculating force on the ball. Wall is pushing the ball left side only, na? That is the meaning. Signs are telling something. It is telling that wall is pushing the ball left side. What I am talking only, I am writing as a equation format. Understood? Now one more teaser for you. You have to fix. You should prove that I am wrong. Understood? Okay. Now same ball. Which ball? Same ball hitting like this. With same speed it is hitting. Everything is same. 1 kilogram velocity, 10 meter per second. But it is striking with wall 30 degree and again bouncing back also with what speed? Same 10 meter per second, same time of contact. During the collision, understood? 0.1 second time they are in the collision. Same question, find the force on the ball by wall. The time starts now. Again with same angle it will be bounced back. Same angle 30 degrees.
It's vertical, it is 30 degrees, right? It's
Vertical 30 degrees, yes. I forgot I became a Gajni. I forgot physics, I forgot the momentum, I forgot ball. Array, sorry, this ball become large after hitting. It is wrong. Same size only. Online students, are you trying or okay, sir cannot see us. So
Sir, -100 Newton.
Trying, sir.
So doing,
-10, just add
Srinidhi,
Yes,
answer
sir.
is -100 Newton. Any supporters, any strong supporters? Try and fail, but don't sit idle. Okay. One should understand the concept of this equation. External force acting on the ball equal to how much? Change in momentum of the ball divided by change in time of the ball. Why I put this vector? Tell me. In which direction force acting on the ball? That momentum only I have to take. That is only meaning, na? When ball is in touch with the wall, in which direction force acting? Like this only, na? Means all momentum components have to take only along the x-axis only, na? Tell me what is initial momentum?
MB.
This is 30 means this is 60 only, na? This is the initial momentum P means what is x component? M into V into cosine 60. Wrong. Plus MV cosine 60.
There minus MB.
What is final momentum?
Minus
When it is
MB.
returning, minus M into V into cosine 60. Rest is history. What is the external force here? Final momentum minus initial momentum divided by time taken. What is final momentum? Minus MV into cosine of 60 minus MV into cosine 60 divided by 0.1 minus 2 M into cosine 60 value how much? 1 by 2 by 0.1. 2 cancels out. So minus M value 1, V value 10 divided by 0.1. Very good. This time, so Jiva gave the very terrific. Srinidhi gave.
Sir, Srinidhi gave, sir.
So very good. I should appreciate Jiva. Jiva also telling. Srinidhi only told. Very good. I underestimated it. Okay, everyone understood now? Definitely you will ask me, sir, give me one more question. You will ask, huh?
Sir, you are about to ask, just turning the
Yes,
page.
sir. We'll ask.
Okay. Jiva is also telling the same. Okay, I will give. This time, this is the same rigid boundary and one ball is same ball, 1 kilogram and 30 degree and hitting with 10 meters per second, but it is sliding like this. Understood? That rigid boundary may be somewhat hot and it is stick to that boundary and with a constant velocity, it is grazing like this.
Constant velocity.
No, 10 meter per second. Just after collision, 10 meter per second. And same time of contact. How much?
0.1.
Same 0.1 second. Now you have to find the external force acting on the ball.
Minus 15. 1 second.
Perfect here. Perfect.
So because that is 0 right?
Very good, very good. Perfect. Understood. You should not use pen and paper. Perfect. Anyway, when the ball is touching the wall during the collision, force will be again along x-axis. Correct or not? So same way initial moment of how much? M into V into cosine of 60. But what is the vertical component perpendicular to wall? 0 only, na? So final momentum equal to how much? 0. So what is external force acting on the ball? To do the same thing. So
Minus
50
100
Newton.
Newton, sir.
Minus 100 by 2 will come, na, Jiva? P2 minus P1 by 0.1.
Okay, sir.
1 by 2 divided by 0.
Yes, divided by 0.1 means 50 Newton will come. Everyone understood, na?
Yes, sir.
One more, huh? Okay. One more means you can do is I will go for next concept. Some more. I have to revise some more concepts. Now, for example,
Yes.
uh,
Yes, direct.
remote is not there, huh? Now, one very, very important Atwood machine. You have seen many Atwood machines in your life.
What is that?
I think you might have seen flag hoisting
Yes, yes.
during January
that.
26th and August 15th. 15th only, na? Understood. One flag, I mean the one rope is attached to flag. They will fold with the flowers. If flowers are expensive, they will cut small, small
Yes,
papers and colorful paper. They will keep. Understood that one circular disc-shaped pulley is there.
Yes, yes, sir.
Very small, but I have drawn very large, and they will attach to the rope like this. Rope, sorry, light string or light rope. It is attached to one wood only, na? Return now. This pulley placed at wood. That's what it is called, Atwood machine. Understood? If you go to countryside, I don't know whether you have seen water well in your lifetime. You are living in apartments and bungalow, so whether you have seen water well or not, I don't know. If you go to your grandmother house or grandfather house in the countryside, definitely you might have seen at least one water well. To withdraw the water from the well also, same thing will be there, na? One rope with a bucket tied to this pulley. One side bucket is there. One side you have to apply the effort. In gym also,
Not
pull up,
not full of.
gym.
Yes,
Yes, some workout machines. Also, you can see this kind of Atwood machine. The pulley, light pulley. What is the meaning of the light pulley? Mass of the pulley almost all negligible. Comparing with to suspended block applying forces. Here mass of the string also light. That's what the string which mass is neglected is called inextensible string also. Understood? So one side I attached one large block of mass M1 and one side I attached one small block of mass M2. I release them freely. What will happen? So M1 will go downside, M2 will go upside. This rope is slipping on the pulley. As pulley I have taken massless point mass, so it won't rotate. If someone is asking light pulley in which direction is rotating, by that question you should not insult them. Because who taught you physics, they will ask you. Will it rotate? No. Why? No mass, no negligible size. Which objects will rotate? Only which have the considerable size only they will rotate. Yes or no? That's what. Now only the rope is slipping on the pulley. Pulley, no rotation taking place. That is the meaning of the light pulley. Light pulley means what? No rotation. No rotation means just a rope is only slipping on the skidding on the pulley. Now if you release them freely, what will happen? M1 will go downside with some acceleration A. As M2 directly connected to M1, M2 also will have the same acceleration A meter per second square. Right now, if you take M1 as your system, for
Acceleration will be 9.8 centimeters per second.
no. String is there, na? If string is not there, if you just drop M1 like this, it will experience one and only one force, that is gravitational force M1 into G. You want acceleration means M1 you have to erase. Freely falling. Freely falling means no rope is there meaning. But it is not freely falling, na? Why? Falling only. Falling only. I never said freely falling. Falling only. Means tension is there. So it is not a freely falling body. just a falling body. Now tell me how many forces are acting on M1? M1 is our system. How many are external agents? Earth is external agent. It is pulling downside with M1 into G. String is external agent. So tension is pulling upside. Net force always acting, I told many times, in the direction of the big force. Direction of the big force, direction of the net external force, both are same. In laws of motion, we never talk about internal force system. Throughout physics, we'll never talk. Understood? Okay? But net force formula, big force minus small force only, na? Second, right? Net force equal to how much? M1 into A is equal to how much? Big force minus small force. Second, right? M1G minus T. Let's say this is equation number 1. Tension is unknown and acceleration also unknown. Now M1 completed. What's up next? M2 is our system. Who are external agents? Same. One is Earth. But who are strong this time? String only is strong. Why? Because M2 is going upside, means definitely string is only doing hard work. So tension is upside, big. Net force also upside only, na? Yes or no? Net force equal to how much? M2 into A is equal to how much? Big minus small. This is equation number 2. If you solve the equation, T value from equation number 2, what I can write? M2A plus M2G. Substitute here. Understood? You will get the acceleration. What do you get the acceleration value? Big mass minus small mass by M1 plus M2 into G will be getting. This is a memorized result. Compulsory, you have to remember on your tips. Again, if you substitute this A value here, you will get the tension also. What is the tension in the string on either sides of the string? 2 M1 M2 into G divided by how much? M1 plus M2. These two are memorized result. And one more relation, if M1 displaced S1 meter downside, displacement of the second block also same distance it will travel, but in the opposite direction. Here I can write one more relation. Displacement of the first block equal to minus of the displacement of the second block. If you differentiate on either sides, I can write velocity of the first block equal to how much? Minus of velocity of the second block. If you differentiate one more time, acceleration of the first block equal and opposite to the acceleration of the second block. These are also very, very important. These are called constrained relation. Constrained means interlinked. I mean, M1 motion affected by M2, M2 motion affected by M1. Connected bodies called constrained motion. These relations are called what here? Constrained relation. Every system has its own. I think time up. Now take 5 minutes break. Next session will continue, but tomorrow is holiday. Okay. Thank you, students. Bye.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.